I'm going to do a quick video on Chapter 3.2 Binomial Theorem, but we're going to get into the factorial notation right now. So let's see, just some factorial basics for us so we understand what we're dealing with. N factorial is equal to some value of n times its reduction, n minus 1 times n minus 2 times n minus 3. So, and repeats. One basic we need to know, 0 factorial is equal to 1. All right? So let's look at a quick example of that. We want to write 5 factorial. It's 5 times 4 times 3 times 2 times 1. All right? What does that equal? 120. Maybe we want to do some multiplication with factorials. It's a good time. 5 factorial times 3 factorial is 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. What is all that total? 120 for the top. 3 times 2 is 6. 120 times 6 is 720. Maybe we want to divide. 7 factorial divided by 4 factorial. Well, that's 7 times 6 times 5 times 4 times 3 times 2 times 1. And then 4 factorial is 4 times 3 times 2 times 1. And we notice that when they're dividing, we can divide out the 4s, the 3s, the 2s, and the 1s. So what we have left is 7 times 6 times 5. So 30 times 7 is 210. All right, let's go on to something else. It's a part we like to call the binomial coefficient. Oh yeah, our good friend, the binomial coefficient. Now we're going to use this in the binomial theorem. You can also find this in your calculator. If you go to your math section in your calculator and PRB, it's your TI-84, your probability and factorial is in there, as well as n choose r. So n over r is also dubbed n and choose r. So and here's how this works. All right, this is what it looks like in your calculator. We use it for probabilities a lot, for combination systems. So n choose r is n factorial divided by r factorial times n minus r factorial. So how does this work? Well, what we're using this for is when we expand these binomials, then we want to follow an n choose r system. We'll get it. My next video will be about Pascal's triangle and how to use that process. But we can use this system as well to find those leading coefficients or the coefficient within each term of the expanded binomial. Okay, so let's just look at an example. 7 choose 4 is equal to 7 factorial divided by 4 factorial times 7 minus 4 factorial. So in this case we have a little bit of multiplication and some division going on. If we expand this out, 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 factorial, 4 times 3 times 2 times 1 times 7 minus 4, which is 3. So that's 3 times 2 times 1. Well, in division, we can simplify the 3's, the 2's, and the 1's. I can take that 4 and go there. This is 3 times 2. So I could simplify this, but maybe I didn't. So I went ahead and multiplied 7 times 6 times 5, which is 210, divided by 6, which gets you 35. Now, I can also simplify. See that? 3 times 2. That will also go with that 6. Bam. You're done there, and you end up with 35. So 7 times 5 is what you have left. Okay, how about another example? I know, they're good. Example number 2, 6 choose 2. If I have 6 factorial divided by 2 factorial times the multiplication of, or 6 minus 2 factorial, then I'll get 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, 2 factorial is 2 times 1, and 6 minus 2 is 4 times 3 times 2 times 1. So again, what can we cancel? Well, we can cancel from the 4 on over. 4, 3, 2, 1. Those go away. What do we have left? 2. I can simplify that to make that a 3. 3 times 5 is 15. Now let's say I didn't do that. 6 times 5 is 30. Divided by 2 is still 15. So 15 is what you're looking for. Alright? I encourage you to pause the video, go back, review. And that today is our lesson on binomial theorem factorial notation. Thanks. See you soon.